We have previously looked at quadratic expressions. So what's an example of a quadratic expression? Well, an expression in general is just something which lives its own existence unconnected to other pieces, whereas what we're going to be looking at in this section, which is quadratic equations, well, a quadratic equation can include the sort of thing we've already seen, but an equation, as its name suggests, must include an equality sign, so this must be equal to something. And quadratic equations we are going to have to write in a form where they are equal to 0. So in general we are going to be looking at ax squared plus bx plus c is equal to 0, where the a, the b and the c are all real numbers. They all live inside this set R with the extra line, which means all real numbers. And we also need that a is not 0. If a was 0, we wouldn't have a quadratic equation. The first way we're going to look at solving quadratic equations is by factorising. So to begin with, we have to solve the quadratic equation 6x squared is 5x. But this isn't in the form I just described a quadratic equation. That had to be in the form with a quadratic expression being equal to 0. Well, if the question is not given to us in that form, we will have to rearrange so that it is. 6x squared is equal to 5x can be rearranged by subtracting 5x from both sides into 6x squared subtract 5x is equal to 0. Now, we know how to factorise this, because there is a common term of x in both pieces. So factorising that x out, we can write this as x into 6x subtract 5 is equal to 0. Now if we have two things which we are multiplying together and we have got 0, that can only be true because one of those pieces is 0. Either the x is 0 or the 6x subtract 5 is equal to 0. So therefore we have that either x is 0 or x is equal to 5 divided by 6 5/6. One thing you may have been tempted to do from the very beginning would be to divide through by x, giving us that 6x is 5 and therefore that x is 5 over 6, which is one of the answers we have got. Why would that have been a problem? Well, when we divide through by something, we need to be very sure that the thing we are dividing by is not 0, because division by 0 is not an operation that makes sense. And indeed, by doing this, we have lost the other solution, the x equals 0 solution. So it is always important to be careful not to divide through by a variable whose value itself may be 0. When we are trying to solve the equation x squared subtract 7x plus 12 is 0, we cannot just factorise out a common term, but we do have a method for factorising quadratics like this. Let's see if we can do this one on site. Well, the two constants must multiply together to give us 12. They must have the same sign, and a little bit of thought tells us that that is x subtract 3, x subtract 4. So therefore, it's either the x subtract 3, which is 0, or it is the x subtract 4, which is 0. In other words, we either have that x is 3 or x is 4. Here is another example where the equation is not in a suitable form for us to try and solve it. So if we're beginning with x squared plus 5x plus 1 is 3x plus 9, we are going to have to rearrange this so that all the terms are on one side. So bringing everything over to the left-hand side, we already have the x squared. If we subtract 3x from both sides, we'll now have 2x. If we subtract the 9 from both sides, we'll have negative 8. And now let's see if we can factorise. If we can, we will need two numbers on the end which multiply to negative 8 and which add together to give us the 2. That is going to be a plus 4, and negative 2, and therefore we have that either x is negative 4 or x is 2. You can see the importance of being able to factorize quadratics on site, which is why you should practice factorizing quadratics until you are able to do it quickly and confidently. We will need the same skills here to be able to factorize 4x squared plus 5x subtract 6, but that's not as easy as the previous ones because the coefficient of x squared and the number on the end are not prime numbers. Let's take the opportunity to revise the ACB method. We've got an A of 4, we've got a B of 5, we've got a C of negative 6, and A times C is negative 24. Well, we need to find all the two-term factorizations of AC. So we could have that as negative 1 times 24. We could have that as negative 2 times 12. We could have negative 3 times 8. We could have negative 4 times 6. And now we could use symmetry to have similar versions such as negative 6 times 4, etc. Do I even have to carry on here? Look, when I add these numbers together in the two-term factorizations, we want to make b. b is 5, which is positive, so the larger of the two factors must be the positive one. If I carried on with this list, the larger factor would be the negative one. Those ones can't possibly work. We need to find which of these factorizations, when the numbers are added together, gives us b, and it's easy to see that negative 3 plus 8 is 5, which is b, so this is the one we want. The method says we go back to our original quadratic 4x squared plus 5x subtract 6, not forgetting now that we have an equation equals 0. We need to rewrite that as 4x squared plus, and instead of 5x we have negative 3 plus 8 x's. Subtract 6 is 0. Then we expand that bracket, 4x squared, subtract 3x, plus 8x, subtract 6, is 0. We factorize the first two terms. The only thing they have in common is an x. That will leave us with 4x subtract 3. Now we have to factorize the next two terms. The coefficients in both of these pieces are even numbers. The best thing we can do is to factorize out a 2, leaving us with 4x subtract 3. And now we can see that there is a 4x subtract 3 in both pieces. If we factorize that out, we'll have an x plus 2 being 0. So therefore we have that either x is 3/4 or x is negative 2. Again, the ability to have factorized that quadratic on site would have saved us a lot of time here, but we can always use this method if we need to. In this example, we have to solve 2x squared plus 2x plus 1 is 0. Can we factorize that? If we can, it would have to have a 2x at the beginning of one bracket and an x at the beginning of the other bracket. The two numbers must multiply together to be 1, so they must be 1 and 1. They must have the same sign, so either we've got pluses in both brackets or minuses in both brackets. Oh, if we had minuses in the brackets, then we wouldn't be able to get a positive number of x's. So we can't have the minuses in both brackets. It must be the pluses in both brackets. But wait a minute, if we tried that, how many x's would we have? 2x times x will give us a 2x squared. Then we'd have 2x's and another x, which would be 3x. This is not a correct factorization. Wait a minute, maybe this doesn't even factorize. Let's check its discriminant. You remember the discriminant is b squared subtract 4ac, which in our case is 2 squared subtract 4 times 2 times 1, which is 4 subtract 8, which is negative 4. Now, we need the discriminant to be a square number if we can factorize this, and negative 4 is not a square number. No negative number can be a square number. So, we cannot solve this equation by factorization. we will need different methods. We're going to develop those in the next few videos.